Our universe is a vast and incredible place, filled with billions upon billions of galaxies. Each one of these galaxies is a massive collection of stars, planets, gas, and dust, bound together by gravity and floating in the immense expanse of space. Some are so distant that they appear as mere specks of light in the most powerful telescopes. These distant galaxies are like ancient beacons, their light traveling for millions or even billions of years before reaching us, offering a glimpse into the distant past of our universe. But some, our galactic neighbors, are close enough to be seen with the naked eye. These nearby galaxies are part of our local cosmic community, and they offer a more immediate connection to the vast universe beyond our own Milky Way. One such neighbor is the Triangulum Galaxy, a spiral galaxy located a mere 3 million light-years away. This galaxy, also known as M33, is one of the closest spiral galaxies to our own, making it a fascinating subject for astronomers and stargazers alike. That might sound like an incomprehensible distance, but in the grand scheme of the cosmos, it's just a stone's throw. To put it in perspective, light from the Triangulum Galaxy takes about 3 million years to reach us, but that's relatively close when considering the vast distances between other galaxies. The Triangulum Galaxy, also known as Messier 33 or NGC 598, is the third largest member of the local group, a collection of over 50 galaxies that includes our own Milky Way and the Andromeda Galaxy. This group of galaxies is bound together by gravity, and they move through space as a unit. It's significantly smaller than both the Milky Way and Andromeda, but it's still a truly awe-inspiring sight. With a diameter of about 60,000 light-years, the Triangulum Galaxy is home to a vast number of stars, star clusters, and nebulae. Imagine, if you will, a vast island of stars, gas, and dust stretching over 60,000 light-years across. This cosmic island is a dynamic and ever-changing place where new stars are constantly being born from clouds of gas and dust, and old stars end their lives in dramatic supernova explosions. That's the Triangulum Galaxy, a place where stars are born, live out their lives, and eventually die, sometimes in spectacular explosions that echo across the cosmos. These supernovae not only light up the galaxy, but also enrich the surrounding space with heavy elements, which can eventually form new stars and planets, continuing the cycle of cosmic evolution. One of the most striking things about the Triangulum Galaxy is its shape. Unlike our own Milky Way, which we see edge-on from within, the Triangulum Galaxy is tilted almost face-on to our line of sight. This gives us a breathtaking view of its spiral arms, which wind outwards from a central bulge like a celestial pinwheel. These spiral arms are more than just beautiful features. They are also regions of intense star formation, where vast clouds of gas and dust collapse under their own gravity, igniting new stars. It's a cosmic cycle of birth, death, and rebirth that plays out on a scale that's almost impossible to comprehend. The Triangulum Galaxy is a veritable star factory, churning out new stars at a rate that far exceeds that of our own Milky Way. In fact, the rate of star formation in the Triangulum Galaxy is thought to be about 10 times higher than in the Milky Way. This makes it one of the most active galaxies in our local neighborhood. This furious pace of star birth is fueled by the galaxy's abundant reserves of gas and dust, the raw materials from which stars are made. These reserves are constantly being replenished by infalling gas from intergalactic space, ensuring that the Triangulum Galaxy will continue to shine brightly for billions of years to come. Within the Triangulum Galaxy lies a region of almost unimaginable star-birthing power, NGC 604. This vast cloud of gas and dust, spanning over 1,500 light-years across, is one of the largest known star-forming regions in the local group. To put that into perspective, NGC 604 is over 100 times larger than the Orion Nebula, a well-known star-forming region in our own Milky Way. Imagine a place where thousands of stars are being born at once, their combined light illuminating the surrounding gas and dust in a kaleidoscope of color. That's NGC 604, a stellar nursery of epic proportions. Section 5, the missing giant. However, there's a curious anomaly at the heart of the Triangulum Galaxy. This galaxy, also known as M33, is one of the closest spiral galaxies to our own Milky Way, making it a subject of intense study and fascination for astronomers. Unlike most spiral galaxies, which harbor supermassive black holes at their centers, the Triangulum Galaxy seems to be missing this central behemoth. In other galaxies, these black holes can be millions or even billions of times the mass of our Sun, exerting a powerful influence on their surroundings. Astronomers have searched for evidence of a supermassive black hole in the Triangulum Galaxy, but so far they've come up empty-handed. Using some of the most advanced telescopes and observatories available, they have scoured the galaxy's core for any signs of this elusive giant. This absence of a supermassive black hole is a bit of a mystery. It raises questions about how the Triangulum Galaxy has evolved and what forces are at play in its core. Could there be something we are missing in our current models of galaxy formation? It's possible that the Triangulum Galaxy does harbor a supermassive black hole, but it's currently in a quiescent state, not actively feeding on surrounding material and therefore not emitting any detectable radiation. This would make it incredibly difficult to spot with our current technology. Or it's possible that the Triangulum Galaxy never formed a supermassive black hole at all, which would challenge our current understanding of galaxy formation and evolution. If this is the case, it could mean that there are other pathways for galaxies to develop and thrive without these massive gravitational anchors at their centers. This discovery could open up new avenues of research and fundamentally change how we view the cosmos. Section 6, Cosmic Comparisons. To truly grasp the scale and wonder of NGC 604, let's compare it to something a little closer to home, something equally awe-inspiring: diamond rain on Saturn and Jupiter. Deep within the atmospheres of these gas giants, under immense pressure and heat, carbon atoms bond together, forming diamonds that then rain down towards the planet's cores. Just as diamond rain on Saturn and Jupiter showcases the universe's ability to create beauty under extreme conditions, NGC 604 highlights the cosmos's capacity for creation on a grand scale. Both phenomena, though vastly different in nature, remind us of the universe's boundless diversity and wonder. Section 7. A gravitational dance. The Triangulum Galaxy is not alone in its corner of the cosmos. It's locked in a complex gravitational dance with its larger neighbor, the Andromeda Galaxy. These two galaxies are connected by a faint bridge of gas and stars, a testament to their past interactions. This gravitational interplay has shaped the evolution of both galaxies, influencing their star formation rates and their overall structures. And it's a dance that's far from over. Section 8. A future encounter in about 2.5 billion years. The Andromeda Galaxy and the Milky Way will collide in a spectacular cosmic event. This monumental collision will be a slow dance of stars and gas, taking millions of years to fully unfold. The two galaxies, each containing hundreds of billions of stars, will begin to merge, their shapes distorting and warping as they interact. And the Triangulum Galaxy won't be left out of the action. Positioned nearby, it will be drawn into this cosmic ballet, its fate intertwined with the larger galaxies. It's likely to be caught in the gravitational crossfire, pulled and stretched by the combined gravity of the two larger galaxies. The immense gravitational forces at play will create tidal forces that could dramatically alter its structure. This encounter could have a profound impact on the Triangulum Galaxy. The gravitational interactions could trigger new waves of star formation as gas clouds are compressed and collapse under the intense forces. It could be torn apart and absorbed by one of the larger galaxies, its stars and gas becoming part of a new, larger galactic structure. Or it could survive the encounter, albeit in a significantly altered state. Its shape and size might change, but it could continue to exist as a distinct entity, forever marked by the encounter. Whatever its fate, the Triangulum Galaxy will be a front-row witness to one of the most dramatic events in the history of our local group. This cosmic event will reshape the night sky, creating a new merged galaxy that will be a testament to the dynamic and ever-changing nature of the universe. Section 9. Conclusion: a universe of wonders. The Triangulum Galaxy is a fascinating and complex place, a swirling island of stars, gas and dust that offers us a glimpse into the vastness and wonder of the universe. From its intricate spiral arms to its prodigious star formation, from its mysterious lack of a central black hole to its future encounter with the Andromeda Galaxy, The Triangulum Galaxy is a treasure trove of cosmic wonders. As we continue to explore the cosmos, we can be sure that the Triangulum Galaxy will continue to surprise and amaze us, revealing new secrets and deepening our understanding of the universe we call home.